Thanks. Good morning. My name is David Benoit, and I'm the CTO of Starscale. We're a small company that specializes in custom systems development aimed mostly at high throughput, large scale, and low latency processing. Collectively, we've worked on large scale VoIP systems, E911 systems, billing solutions, high performance athlete management systems, real-time foreign exchange systems, market data feeds, et cetera. Okay, but all of these projects had one really fundamental piece in common. They were all heavily data-driven. The data that we store in all of these projects and all of these things that we do is valuable. And the interaction with that data needs to be three things. It needs to be simple, correct, and fast. So I want to start with an example of a data-driven application. This is one from a long time ago. And hopefully this will give you some motivation into what we're doing and why we're doing it. So the example is something called enum. And so everyone should know what a phone number is. But in the VoIP world, figuring out what server is responsible for receiving a phone call is actually kind of complicated. It's done mostly through a service called enum. The basic idea behind enum is also what causes or allows things like number portability and wireless roaming to work. You can think of enum as DNS, but it's not as organized and hierarchical. And you need to find the best server for a number, which means that you need to start with the whole number and look for the best match there. Because Jenny doesn't want her phone calls going to Verizon, and Verizon wouldn't know what to do with them if they received a phone call for her. So it's common to use a big list of prefixes, but getting the right answer requires up to order n, where n is the length of the phone number, order n queries, where you start with the whole number, look for a match. If you don't find a match, remove a digit, look for a match, remove a digit, look for a match, and keep going until you either don't find something or you find something. This pseudocode is basically what most real servers do. Okay, the algorithm is correct, and it will find the best match for this type of storage. But the placement of the processing and the intimate knowledge of the data representation, I argue, is in the wrong place. Okay, not only that, but this is a lot of round trips to the database. Maybe the database is local, but every single round trip involves complexity that's unnecessary. It has network traffic, it has parsing of the statement, execution by the query engine, results sent back and parsed by and interpreted by the application. I argue that the application programmer shouldn't have to know any of this. They should only have to know the specific questions that the specific questions and the actions that they're allowed to make. So what should the code look like? This pseudocode is basically how we implement this. Now, we use a non-blocking interface, and the syntax is a little different, but the idea is this. Ask the database a question using the interface, the information that you know, and get the answer that it can give you. There's no need to know the schema. There's no need to involve the application in the intimate details of the data layout. And if and when, because you always will, decide to change the database design, the application doesn't have to change unless you need it to. If you decide to change from a big prefix list to find these numbers to using regular expressions, you can do that. If you decide that North American numbers have to be handled with one table and one method for looking things up versus European numbers have to find in a different way, you can do that. That implementation detail is just that, it's details. The application doesn't have to know. It might not be immediately obvious, but this is also just a single round trip to the database, which reduces overall latency and places the lookups with the data. So there's cache locality that you get when you're actually doing the query, and that further optimizes things. So this is nothing new. Encapsulation and data hiding are fundamental tenets of object-oriented design. And you build an interface and you publish that to your users. You control what's necessary for its implementation, and you're free to change any of their internal GUI anytime you want. As long as the interface remains the same, your users don't have to know. When all of us design systems, we should be doing the same thing with databases. Why do we give out raw SQL as our interface to the database? We should have interfaces that we use, and under the hood, we can do what we want. So I want to show you now how we do this and why we do it, a few of the benefits that we've gotten out of this. And there are, I mean, what I've just shown you is basically to show the simplicity of this, but there are many more. So let's walk through an example. Let's build a simple wiki where I can get and save content, and I want some simple permissions to determine who is allowed to edit a page. Okay, we'll include some account management functionality that we've written in another project, and we can include that as part of this. Just like an object can be included, or a class can be included from another part of any other object-oriented programming. So here's this possible schema for the pages. It's kind of boring. Here's a possible schema for some permissions and a whole bunch of constraints that we want on those things, like we want pages to be unique and we want users to exist. But those things shouldn't be exposed. They can be available if anybody wants to see it. If they want to look under the hood and see how the details work, they can do that. But it should be, as far as the application is concerned, it should be a library that they use. They're details. They're implementation details that aren't important to the application. The application only cares about the interface and possibly the computational complexity of making the request. So what is the interface? What would be public in this class that we're making? Well, it's the stuff we want to do. We want to get a page. Okay, somebody makes a request, we want to get a page, we want to pass in the ID and get that. We want to set a page content, so we have a page number and some content that we want to set. So we basically take some input parameters, the information that the application has, and we do some stuff and return the result. This is what the application wants. The details of how we do that are hidden, and the ability to do anything else should be removed. So there's no risk of a junior developer or a senior one that doesn't understand what they're doing causing massive table locking or table scans because of a poorly designed query that they have in their application. The operation of the database is in the hands of the experts, and the application can do what it needs and nothing more. So similar to a function or a method in a class, we define what we return and what we take as arguments. But we also define what results can come back. So in this case, it can either work, we can have some exception failure, or we can have a specific failure that the page was not found. The results contain the content, some creation info, when it was updated, and the revision number of this specific page. And we specifically note, and I'm going to get to this in a minute, we specifically note that there can only be one row that comes back. So we get to optimize a bit on the parsing because we know this. Similarly, this is the basic definition of a set page method. You take in the page that you want to do, the text content, the base revision, the status. They can either work, they can be some kind of exception. The page is not found, permission denied, or there's some kind of mid-air collision if you're doing any kind of revision control. Note that this one, since we're creating a page, there's no results, so we don't need to define them. So what would be the alternative to doing this if we didn't have this kind of syntax? Well, the alternative is what a lot of people do today. The application needs to know the structure of the data, but inevitably, the structure of the data is what makes it complicated to answer simple questions correctly. So what about permissions? What about conflicts? What about anything else that I don't know about today, but you've decided to add it to your wiki system, and now it impacts how you can get content back? What happens after you refactor the database because you've you've now got a massive amount of pages and you need to index them a different way or structure pages a different way or you want to archive things a different way. The simple query doesn't work. This interface doesn't work. So what do we really do? This is what the form of the functions look like for us, okay? And I'll get to how we get there in a minute. But basically, it's a status code for simple indication of success or failure. We declare the result sets that we're going to select data into. These can contain 0 or 1 or more rows. And in our definition, we define how many can come back and test that that pattern is never violated. So there's a massive amount of code that can go in here. And this is our basic flow of what we do. We take a concept of what we want to do. We want to create a wiki, okay? We group related ideas, so get pages, get permissions, set permissions. We determine the input parameters that we're going to have. We determine the status codes that we want to return from that. We write it down, and we hit go. From that, we get a C++ library that only allows us to do those interactions that we've defined. We get HTML documentation about what we've written down. We get a test harness for all of the stored procedures we're going to write. And we get stubs for the functions that we're going to write in the database. After that, we have a clear division of responsibility. And this is one of the first really big wins that we've had. This allows for parallel development. Okay? If you're a small group where you are both the application developer and the DBA, it allows you to only wear one hat at a time. So I can go off and write the application and not have to think about SQL, and then I can go live in SQL land and only think about writing to the interface that I have. In either case, you have the documentation that you've written down as a reference. So you can say, well, this procedure needs to return this status code in this particular instance of input. For the DBA, the test harness allows for verification, regression testing, et cetera. And this is very hard to do with raw SQL. Think about putting raw SQL in an application and then being able to test what you're doing. How do you do that? It's hard. And most of the time, people either don't do it or they do a minimal amount of testing to basically make it so that the query is syntactically correct. For the startup with not enough database experience, it also allows you to go in and write something that's good enough in your database so you can return some information out of procedures that's good enough for you to write your application and good enough to get you a proof of concept. And then you can bring in the experts and refactor your database, and your application doesn't need to change. So no more sending SQL statements, not even prepared statements. And we can leverage the benefits of pre-compilation of functions within the data server. So but one of my pet peeves with Postgres in particular is that I wish there was a way that Postgres could do a lot more of the checking on the creation of a function instead of on the first execution of it. First execution is when it actually does the compilation. I'd like it to shift to when you actually create it. We can also lock down the database. So what we do is our applications have a specific login that they use, and we drop all permissions on that user except execute. The only thing that they're allowed to do is execute the functions that we've defined for them. And we define functions in a schema that they're allowed to view. And then no other functions in that schema that they can call. We also never have to worry about the fact that any of our arguments will be interpreted as SQL statements. They're variables. They're not interpreted. So little Bobby tables is safe with us. Nobody got that, really? Oh, okay. So we also have it's also possible to have different versions of the API. So change is inevitable, okay? So things evolve, your data changes, you decide to save different information, you decide you want different information back, whatever reason there is, there are going to be changes to your database at some point in time. So we designed this to work so that you can change the API, but essentially what you're doing is adding an overloaded version of that function. If we have two versions of get page, maybe one cares about just the content. Maybe the first implementation just had set a page, here's the content, and get a page, and here's the content. It didn't have the concept of who created it, when it was created, or what the version was. Well, that application can still run because we can write a new version of that get page method that doesn't return the extra information. And we can have another version, the new version of the method that returns all the information that we want, and the new applications can call that one. You just simply call them get page v1, get page v2. And under the hood, that's all managed. At the application layer, it's just called get page. You've included the right version of the header file. But our biggest win has been this. I burned through these slides really fast. Our biggest win has been this, the ability to test everything. So we write extensive tests on all of the functions that we defined. Remember, this isn't SQL, okay? So there's actually logical constraints on what the input should be, what the output should be, what effects there should be on the database, what preconditions are met, what postconditions are met. We test that input is valid and gives back the right errors. We test that all the errors are actually returned. We test preconditions in the tables are met. We test that postconditions in the tables are met. So run get page and make sure that the database has not been affected in any way that we didn't intend. Run set page and make sure that you actually set the content of the page. And make sure you didn't set the content of any other page. You can test all those things. If you're letting an application use raw SQL in the application code, they can do anything they want. You can have testing around the execution of an application, but you can't do unit testing of what you've defined as their interface, because there is no definition of an interface. It's open. When we refactor our databases, when we change the internal layout, when we change how things are done, we split things up because we've had a better idea, we have to denormalize something because it's becoming untenable. We can run all of these tests and make sure that anything we did doesn't break anything we need. I use this a lot. Okay? We go in, we change something about how some transaction is stored. Well, I want to know that everything that I've tested for still works. And when we get bugs, we can add a test for the bug. And we can do regression testing when we fix it, or when we make changes. We have a logical unit, and we can test it. This is huge. So my real reason for giving this talk, and we're going to have a lot of time to discuss it, is to ask, how can we make this better? So if we follow this methodology because we think it allows for a good split of functionality and good documentation of what's needed and good flexibility in the application and good flexibility in the database, if this is the interface that we can present to application developers, how can we make it better? You know, we've written application code that uses the same framework to talk to PostgreSQL, MySQL, SQL Server, and Sybase. I don't want to call it the new ODBC, but because that's tired and dead. But it's a new way of thinking about accessing a database. You access it with methods. It's an API. The application shouldn't care what it's talking to in the end. The database should support the functionality that it needs to be able to get this information back. The arguments, the return status, the definitions, those are all the same. The implementation of that function in a specific database language, that's going to be different. And that part is what should be hidden from the application. So could this idea evolve as a standard? Could we have some better application interface than what we have today, which is just SQL, or the ability to have functions and write APIs on top of them, which is what we're essentially doing. So functions are great, we have them, but can we make them better so that they are the interface? Can this, in general, act as a high-level language for databases? And that's essentially it. So I really would like opinions.
I guess the question I have is, how do I convince my developers that this is a good idea? My application developers.
Sorry?
How would I go about convincing my app developers that this is a good way to do things?
Are your app developers DBAs?
No.
No. Then tell them they never have to write SQL again.
Well, they use Rails, so they don't really have to write it down.
Right, okay. So I guess one of the things I'm going for here is that this doesn't require an ORM, okay? And specific frameworks like Rails or Ruby, their interaction with databases, they require specific designs of databases that aren't always ideal. You have to fit their model of how it's done. And if you don't fit that model of how it's done, then you're SOL. I've had people say, oh, well, I can't connect to your database because you don't have this, instance ID of blah, blah, blah. And I'm like, so? Well, Rails won't talk to it. I don't care. My data model is correct, and I'm not going to corrupt it just for that model.
I'd say no, but with Rails, it works well for OLTP applications. That's really what it is to me with web app. It's very highly transactional. So
Yep.
are you saying you'd say to supply if it's better in the data warehousing context, or what I guess what I'm trying to get at is what model do you think, in particular, something like Rails or Django, doesn't fit well.
Right. Okay. So specifically for transactions, everything we do is transaction-based. And one of the really nice things that we have that we've found about this is that the transaction is just an API call. Right? It's as simple as that. I don't have to, in my application, say begin transaction, do a whole bunch of stuff, commit, handle all the exceptions that can happen from that. Certainly, frameworks like Rails or Django they wouldn't have to, I suppose. They could use raw SQL, but they could adopt this. And if there was better support for this concept, that the application's interface to the database should be through functions or through this kind of an API, whether it's this or something that's slightly different, maybe we can get some optimization out of that. Maybe there doesn't have to be as much munging of stuff inside of Django or Rails or wherever it needs to be to have really intimate knowledge about the database and how the tables are structured and relationships there to let you do stuff. And those frameworks like Django and Rails, they still allow you to corrupt stuff. Right? What I'm proposing here is that you have this API and you're only allowed to do that. So you get good interfaces out of these frameworks, but they still allow you complete untethered access to the data. And as somebody who really values my data, I don't want that. I don't want to hire a junior developer and let them go free and write something that, just because it passed a code review and somebody missed something, now it's corrupting things. That's really bad.
Separating
No, actually, when we do stuff in the projects that we have, we end up doing both sides. So in this wiki example, for example, like I wrote the definition of what I wanted to do, and then the first thing I do is I go off and write the stored procedures that actually implement that. The reason I do it that way is that exposes to me anything I forgot. Oh, this specific constraint is there, and it will produce this error, so I'll add that to the interface. And then once that interface is done and perfected, I go off and actually the next step I do is I write all the test cases to make sure that everything I did actually works. And I perfect that and refine it down to the point where I know it's going to work. Then I write my application. So when I said, your application developers never need to write SQL, you can live in that world if you want to. But for me personally, it actually makes my life easier just having this logical separation of what is responsible for what. I mean, I have queries in some of the Forex stuff that we do that are 200 lines long. It's doing multiple joins on multiple tables to figure out what permissions are there, what rates need to be used, that kind of thing. And I don't want to have that in an application. I want to have that somewhere where I can specifically test that every single execution of that gives me back the exact answer that I want. Simple things like having numeric types, and doing the math with numerics, where I need 12 decimal places and I need it to be exact, and I don't want a floating point representation of that to screw things up. Those kind of wins, even though they're database and even though it's SQL and I need to write it and I need to remember all that stuff, it still frees me from having to worry about, IEEE specification of how something is done, so that I know that I need to watch out for stuff. I know that databases handle numerics properly. Done.
I think a lot of it comes down to, so when you start looking at it like this, you get in your normal point-based question on, for the stuff that's going to be calling those functions, procedures, whatever you want to call them, how frequently does it call or change with your stored procedure? If they're always changing at the same time, you're really not going to get much benefit out of that encapsulation. If you've got a lot of shared data that's getting used across many applications, then typically something like this you're going to be a lot more happy with, because you're usually building data sources anyways. Even if you're building the application layer, you still end up doing that work to separate.
Yeah.
But if you've got situations where, like all access is going for a set of business services anyway, there's a lot less benefit for something like this, just because typically you're going to end up changing both components whenever those changes happen anyway.
True.
So it seems like the more you have data that can be shared across a lot of different applications, the more benefit you get by pushing out encapsulation.
Right, but even in that instance, I would say that pushing that logic or that execution or that even the writing down of the query, instead of having it in the application and executing it there and putting it in the database, it gives you a better separation of things. Instead of having a database and an application that are like this, I've got specific things that I can ask it, and maybe I change those every time I change the definition. But at least I can go back and I can run all my tests that I've had previously, and maybe I have to modify them for the new interface. But I still know that I have some more level of confidence that things are going to work, instead of having to stand up a database, my business middle layer that handles things, and then do more of an end-to-end test to be able to find out whether the queries that I have in this business middle layer are actually working.
Right. You still got a cost there typically, especially part of it has to do with how much your application developers are separating from your DBAs and where you're splitting that knowledge. Because you're kind of forcing, because some of what the teams will do is then tend to want to inject more of the business logic into those procedures anyway, to avoid extra round trips and those types of things. So then you potentially get situations where what you're trying to encapsulate may not actually be the database logic anymore, because the queries are now kind of breaking encapsulation code because you're starting to inject some of that stuff down into the procedure.
Right. So I've actually heard this heard putting too much of the business logic inside the database when you define these functions. I've heard this from a few people. And my argument is basically the data is your business. You know? If the data isn't your business, then, I mean, why aren't you using fopen? Like, you're using a database to structure your data and have relationships between things. And even those simple relationships between data that's in different tables, that's part of the business. That's part of the logic of how things work.
And I don't mean that to say that that's not, you've got business rules that even in the basic schema.
Yeah.
Relationships, reference functionality, those should all be enforcing business rules. It's more, same thing, you want to componentize the business functionality too, so that, I've got, same thing, I've got business rules that change all the time. I want to go one place and change. So, ideally, you want to go keep that. So, like as an example, one thing
Right.
Standard, basic, selects, answers, update.
Right. So
They're also for automatically generated.
yeah. So I mean, this example that's presented, it's a simple thing, right? Like this is the type of thing where you can write it in the afternoon, even using this kind of stuff, even using an ORM or a framework like that. But when you get into, you know, larger applications with more tables and more constraints and more requirements around data integrity and what needs to be where and what permissions people have and what things need to be checked and what things need to be written down for compliance, that's where I just want a function that I call with the data that I have, and all that's done for me. Now, whether that's written by an ORM or whether it's written the way I do, that we do it, it's kind of like using, you know, one language versus another in my head. But I'm much more comfortable having 150 tables in my very large schema for the application that we're building and only having 2 methods that the application can call, and those 2 methods are responsible for all the interaction for the data that's in there. Yeah.
From a planner standpoint, did you do like a bulk performance test of a traditional ABBC call with the SQL versus using these procedures?
Yeah, we have. I don't have the numbers here, but it is significantly faster.
Does it store the plans at all in the procedures? Because reading the manual and some research online, it sounded like after the first execution of a given query inside of a procedure, it stores the plans so it doesn't have to replan.
Right. So a few optimizations are actually done by most data servers. One, it does cache the query plan. It can cache access to tables that it's going to know. It can do a lot of optimization ahead of time, instead of just having I received some SQL, well, let's find out what it is and do all the parsing that way, and then executing into the query engine, and then all of that stuff every single time. And yes, there's prepared statements, and you can do that kind of thing, but prepared statements only work on a per connection basis, so that if you've got connection pooling coming in from multiple instances of an application, well, now you have to have multiple instances of the prepared statement, and you know, it's less and less compelling at that point, where if you have this API, you have this function that's in there, well, okay, if we know people are going to use them, well, maybe we can do better optimization than what we do now. Maybe we can do better caching of query execution plans and stuff like that. Maybe we can give much better error reporting, much better ability to return results, much stronger interfaces, that kind of thing. If the community decides that this is a good idea and that this is the kind of interface that people should have, and that tools like ORMs and Rails and Django or whatever, that's what they would use. Well, imagine you go into Django and you say, well, I want all these relationships of the data I have, and these are the actions I want to do. Okay, well, now define what you want to do. You know, it could be click and drag affect tables that way too, right? Like your tools could generate these functions for you. There's nothing stopping you from doing that. But you still, out of that, can get the testing, you can get the versioning, you can get the query optimization, you can get all of those things that would still benefit them. I mean, think of it as, you know, there's always this argument between what's faster, writing in C or writing in C++. Well, there's arguments on both sides, right? C is better because you have ultimate control over what you want to do, and you can have this. And then the arguments in C++ are like, well, you're operating at a higher level, so there can be higher level optimizations that can't be done at this level. That's what I want to do here. I want to, SQL's great, we can optimize it, we can do all kinds of stuff to make it better, but can we make an interface at a higher level that provides better optimization because it has a broader view of what's going on? That's all I have. If there's any other questions. Good? Thank you.